Hello, good morning. This morning we're going to look at solution chemistry. And under the solution chemistry, we're going to look at diluting solutions. How do we dilute acid and base during our titration? All right, commercially available concentrated solutions are often called stock solutions. For example, commercial available concentrated HCl is usually a 12 molar solution. And when you want to dilute that, the question is how to prepare 100 ml of 1 molar HCl solution from 12 molar HCl solution. So these are the process we're going to take. The obvious answer is dilute the concentrated HCl, that is 12 molar solution, which is the stock solution. But what volume of HCl should we dilute? What amount do we need to make that solution? To obtain this value, recall the definition of molarity from the previous lesson. Molarity is moles of solute N over volume in liters, L. Alright, hence, moles of solute equals to molarity M times liters of solution L. Now, having got that, we now have moles of solute as N, which is Mi times Vi. The subscript I stands for initial. So Mi equals to initial molarity, Vi equals to initial volume. So add water to the solute, the changes concentration and volume, and that will give us the second. Thus, the mole of solute N equals to Mf times Vf, which is your subscript F stands for final volume and final molarity. So in other words, when you combine the two now, we have MIVI equals to MFVF. So that means this is the formula we're going to use for dilution. First is the initial molarity times initial volume equals to final molarity and final volume. So at least when you, from the questions you are given, the question is how to prepare 100 ml. To prepare, that is your final volume. You want to get this volume of 1.0 molar solution. This is your final molarity. But your initial molarity, the starting molarity of the solution that you want to dilute, is 12 molar solution. So this is your initial molarity. Initial volume is what we are looking for. Your final, because you are going to prepare 100 ml, that is your final volume, and this is your final molarity. So it makes our work easier. You can easily get your Vi, right? So in the example, Mi equals to 12 molar. Our Vi is to be calculated. Our MF, the final molarity is 1.0. Our VF, final volume is 100 ml. So substituting that values in the equation above, that is MI/VI equals to MF/VF, we should get 12 times VI equals to 1 times 100 ml. All right. Now to get your VI, you divide by 12 molar. That is 1 times 200 divided by 12 will give us 8.33. So you are going to you need a volume of 8.3 ml of the molar solution. In this case, you are allowed to use any unit as long as volume initial and volume final have the same unit. If the initial volume and the final volume are the same unit, then you are free to use any unit of your own. If the initial volume is liter, the final volume can also be in liters. You don't have to convert from milliliters to liters or liters to milliliter anymore. That will be okay for you. So take a clean 100 ml of volumetric flask, add about 25 ml distilled water, then carefully and slowly add 8.3 ml of that 12 molar solution HCl, and add more water to bring the level of the water to 100 ml, total of 100 ml. So that means when you are doing the dilution, you don't add 100 ml directly. Otherwise, you will go above the 100 ml, because you remember that the initial volume of your acid you are going to measure is 8.3 ml. So that means this 8.3 ml should be part of your 100 ml that you want to prepare. Otherwise, if you add 100 ml directly to your concentrated 12 molar solution of 8.3, you are going to get 108.3, which is wrong. You are going to prepare 100 ml. So in that case, you only need part of 100 ml to add to 8.3 to get to 100. That means indirectly you are subtracting 8.3 from 100. We subtract 8.3 from 100, you get 91.7 ml. So that means the amount of liquid you need or water you need is 91.7 ml, because you're going to add 8.3 to it to get to 100 ml. I hope that is clear. So you add more water to bring the liquid to your level 100 ml. So let's take another example. A stock solution of 15.8 molar HNO3 is given. How many ml of the stock solution are required to make 0.25 liters of 0.12 molar HNO3? Right, this is the stock solution. We want to make the solution of molar solution of 250 milliliter, which is 0.25. So we use the same formula, MI/VI equals to MF/VF. MI is 15.8, VI is to be calculated, MF is 0.12 molar HNO3, and VF is your 0.25 liters. So using your formula above, you are going to substitute the values and find the amount of VI. So 15.8 times VI equals to 0.12 times 0.250 liters. So your VI is going to be 0.12 times 0.250 over 15.8, and that gives you, of course, the molarity cancel molarity, that gives you 0.0019 liters of the liquid. So that means this is the amount of liquid you need. You are converting this to liters, so that to milliliters, so that you know amount you can measure. Remember the stoichiometry, liter cancel liters, divide by multiply by 1000 will give you 1.9 milliliters. So this is your amount of concentrated acid that you are going to measure. And if you want to make 0.25 voliters, of course 2.25 voliters is about 250 ml. That means you're going to subtract 1.9 from 250 ml to know the amount of water you are going to add to this 1.9 to get to 250 ml. All right, so let's look at an example now. It's not solution. You can pause this problem so that you can solve it on your own as you are listening to this lesson. It's not solution of 16.0 molar H2SO4 is given. How many milliliters of the stock solution are required to make 0.1 liters of 0.22 molar H2SO4? All right. Your MI, what is your initial molarity? Initial molarity is about 18.0. Your final molarity, that is the molarity you want to get, it's 0.22. That is right here in the question. Your VI, initial volume, is what we want to calculate. You want to know how many volume of this bench solution you are going to measure to dilute to 250 ml. So your final volume is 0.10 liters. So your initial volume now is 0.22 times 0.10 over 18. Once you do that, everybody get your calculator and work it out. That should give us 0.001 or 12. Thereafter, you have a 2 at the back. All right, so calculating this, you should get something like 0.0012 times, that is, you are converting milliliter to your liter to milliliter. That would be 0.012 times 1000. That will give you 1.2 milliliter. All right, so this is the amount you're going to measure. All right, the second example, let me go back. So this is the amount you are going to measure to be able to get your volume of 250 ml dissolved in that. This is another example. I want you to pause this and see how you can solve this. Make sure you go over this very well, interaction, and then you can do more problems at the end of it. I will give you more assignment to work on. All right, let's do some practice problem. Pause this video to be able to answer this question. All right, this is another question. They are all mixed up together. You have molarity question, we have dilution question, so you have to figure it out. Make sure you answer these questions and send the response to my Google Classroom as your ticket at the door. Alright, these are the 5 questions I want you to practice and send to my Google Classroom as a response. I'll see you tomorrow again. Thank you for listening. Bye-bye.